Hello everyone. In this video we look into Git. There are many videos in YouTube talking about Git and more detailed versions available. The reason I am recording this video is to give a straightforward hands-on Git explanation and walk you through all the key commands of Git so that you can do it by yourself, and especially focused tune designed for the people who are beginners in development, data science and artificial intelligence aspirants. You may not need a very sophisticated branching and all the features of Git, but when you start developing or you're doing a future projects, it's highly recommended that you use Git for all of your data science and AI projects. So let's get started. We'll start with what is Git, or even before that, other version control tools along with the Git. Well, Git is a version control tool. I will quickly talk about what it is. But there are other tools also available, like you have Subversion, we have Mercurial, we have CVS. CVS is a very old one. It's the initial release was in 1986, and Mercurial is on the Subversion is 2000, year 2000, and Subversion was a standard before the Git. So most of the software developers were using Subversion. It's also termed as SVN. When you see SVN, you're talking about Subversion. It's a centralized version control system. And then comes Git in 2005. Well, at the same year, in fact, the same month, April 2005, Mercurial also, the first release of Mercurial also is done, but Git is by far the most popular. So if you know Git, you have enough, you don't have to look into any other version control tools. It's open source, it's fast, it's reliable, it's secure, have everything you need for version control. So what is Git? Git is a distributed version control system for tracking changes in any files, originally designed for coordinating work between software developers, programmers, but it can be used for any file control system, any purpose. The question, why Git? How can't we just do it the way I'm doing right now, without using Git? Well, you could, but you might quickly run into a couple of problems, bump into a couple of problems. For example, let's say when you're updating any files, making changes on the files, talk about any small document. For simplicity's sake, do not worry about coding, but even any document, the way you do is you do some changes and we save it. So you do some changes and you save it. Okay, you save it. And then after multiple savings, if you are doing the changes in the existing versions, if you normally try to create a copy of it, we might name it as version 1.0 or something with some file name. All right, and then you take a second copy and made version 1.1 and you start doing changes here. So you're not touching this one anymore because you want that to be safe. If you go back and mess up with something, you always have a previous version to fall back. All right, and if you do some more changes, we might call it as version 1.2. If you make a significant change in the files or in a code, we might call it as 2.0, and it keeps on going. The reason you maintain the multiple versions of the same file is that if something goes wrong, like you mess up with the previous code and you don't know what you're doing anymore, you always have a version before to fall back. All right. This is a very typical practice. I'm pretty sure you'll be doing with whatever presentations or any document files you do. It's the same thing applies also for the code files. But the problem with this manual way of doing is you are maintaining too many files as number one. And it's really difficult to understand what changes you have done from one file to other file. And even more difficult if you want to go back to, let's say, 3 weeks before code, how do you know which version is 3 weeks before code? Well, we can even put the date and time in the file names, but things get pretty complicated over a period of time and you don't know what you're doing and you pile up a lot of files for maintaining one file. Think about you're working on 100 different files. You keep on making versions of it. Let's say 20 versions each, you're talking about 2000 files and it becomes quickly messy. And also we have to sync the versions. Forget about it. It doesn't work. It might work for a single file for a very simple coding, but when you're doing a project, manual versioning doesn't work, and that's where your version control comes into picture, the version control software systems. These softwares, Git for example, automatically maintain all of your versions. You can go back and forth in the time, and it's preserved all the versions wherever you commit. It will be more easier for you if I explain with a hands-on example. Okay, yes, going back, that's what it says. It tracks the changes you make to the files. You can record has been done. You can revert back to a specific version should you ever want it or needed to. You normally do it when you mess up something or you want to refer back to the previous code for whatsoever it is. Git also makes it easier for collaboration. This is actually even more important point. Think about multiple people working on a same code or a same document. All right, it quickly gets complicated if both the people are working in the same file or in the same project, for example. So one has to wait for others to finish and then send the file across, and then he can work on. While he is working, he has to wait. What if you have many people doing it? Even if you create something with everyone can work in the same file collaboratively, the chances that one messing up with the other work is very high, and deleting, modifying lines of codes, and we don't know who is doing what, really difficult to track. Git does it all in a very nice fashion, and that's why, I mean, you don't expect any developer or any projects running without Git. So Git has become the standard, and if you're a developer or even a data scientist or AI professional, you're expected to know and use Git. Okay. All right. So that's why Git. And as I said before, I'm going to get quickly install stuff and start doing it. And I expect you to do along with me. If I'm going a bit faster, you can pause the video and do it. And when we finish this video session, then you should be good enough. I mean, you should have already done all the key commands of Git. All right. So you can install the Git by simply typing in, go to your browser, Git download. You will find a site called Git-SEM. You can go here. You have versions for Windows, your version for Mac, Linux. You could pick up whatever version based on your operating system. For me, it's Mac. It's already downloaded, so I'm not going to do it. And to set up the initial Git, these are the few commands as you can see in the screen. I'm going to go to, let's say actually, let me just go to the desktop. My desktop is clean, which is good. Okay, cool. Let me create another small desktop here for me so that I can just use. Okay, so I have nothing here. I'm gonna right click and create a folder. I'm gonna call it as Git. Where is it? It's auto set. Okay, no problem. So I'm gonna call it as Git tutorial, or some kind of project. Okay, and then inside that I'm gonna create a file, and before that let me simulate different computers. So I'm not gonna create files here. I'm going to create a folder called developer1, dev1. Let's assume that there is a developer1, and he is working on this computer with this folder. All right, and then inside this I'm going to create a file. I can do it using any text. Why TextMate cannot be opened? Here we go. So I have a TextMate. You can use any editor if you're using Text Wrangler or any IDE, or even a notepad in Windows if you're reading Windows. Anything is fine. I'm creating a HTML file. So I'm going to save the file first. I'm going to call this file, it's anyway saved in desktop, that's good. I'm going to call this file as index.html. I assume that you have HTML knowledge. So I'm not going to use any data science or machine learning codes here. I'm going to use simple HTML because the goal is to teach you Git. So let's focus on that. I'm going to type in, well, a few HTML lines of codes. I don't know if it is visible, so I'm making it big. It's now 300, so it should be visible. So I'm going to quickly type in a few lines of code. Head, and you might have a style inside it. You don't have to bother about this one if you're, I expect this is pretty basic, but even if it is if it is not something you're aware of HTML, you do not have to bother. So you can imagine any file, for example. I have a head, I have a body, and I'm going to write something like h1. Oh, okay. I'll say div. Div. Okay, cool. So I have created this file, I saved it, and this file should be okay, that's interesting. Where did I save it? Saved in, oh okay, saved in desktop. So I should be saving in from desktop. I have a folder called git tut and then div1. So that's it, that's where I want to save this file. If I do that, I will be seeing this file. It's HTML file, which means if you double click it, it opens up. There is nothing there because I didn't really put anything. Let me put something. I'm going to say h1 header 1. This is what is this? Git tutorial. All right. Kind of tremble for simple spelling mistakes sometimes. Okay, so let me go to the browser. Okay, I'll just double click this one. So I'm maximizing this. Okay, so that's the file I just created. I've just written a few lines of HTML code and written a big header called as Git tutorial. Okay, things are pretty clean till now. Okay, now I want to initiate a Git repository. Simple reason, I want to track this file and I want to track every single version of changes I'm doing from here. For initial setup, you should be, I'm going to use a pure command line for now, right? There are GUIs available, but if you know command line, GUIs are actually doing the same thing. I'll also introduce a GUI graphical interface application for Git, but for now I'm going to do a simple command line. I'm using terminal in Mac. So in Windows, you can use command prompt. So you can simply type in command prompt. And if you've installed the Git from, if you type in Git, okay, let me also make this little big. And okay, let me also increase the size. Pretty big. Hope it is visible. Okay, I think that should be good enough. So, well, normally the original size is good for, I don't know, for the screen I'm just making it max. I'm going to go into CD desktop because, okay, that's where my folder, which is git tut, is there. In that I have yeah, I can say ls I have div1, so I said div1. Okay, so I'm in div1 now and I can already see my file, which is html dot index.html. all right, I can even look into the contents of it simply by typing a cat. If it is window, you can click and open it, or you can use type command in Windows. So that's a simple file you have just created. Okay, wonderful. So I want to initiate a Git repository so that I can keep track of everything happening on this folder. Well, this folder is my project, so I want to keep track of everything happening in this folder. For that, I simply use the first command called git init, which is essentially git initiate. All right. When I click it, it says that initialize empty git repository in the same folder. It has created a folder called .git. If you have hidden folders, system folders not showing, you'll not be able to see it, as I'm not able to see. As you can see this, I don't see that git .git folder, but you know, in the terminal, if you type in ls, okay, ls -a, of course, so you can see that. Let me clear this for you. I think it's not required. You can see that. So there is a folder called .git. It was created when I run the command git initiate init. All right. So this is actually git folder. This is the git folder. It has everything Git is tracking. Everything is in here. All right. If you simply move this folder after out of tracks to another folder, your entire Git repository is moved. So there is no hidden files, there is no registry enters, there is no dynamic linking libraries. It's just a folder. Everything Git does stores exactly in this folder. Okay, so it becomes very portable. If you want to move your repository to some other location, you can copy this entire folder, the Git folder, along with the files, move it to another location. It works off the box. It even works with all kinds of operating system. I can move this folder from Windows to Mac to Windows. It works perfectly fine. So there is no external dependency. Everything Git does is stored in the hidden folder called .git. Okay, I'm gonna clear the screen. Now I have initiated the Git already, right? As the slide says, we need to also declare my name and email ID. Okay. I'm gonna say git config user. Okay, I can say global if you want to make it global, but I don't want to say and --global. If you put it, then it takes for all of this in the system. It takes care of it. I'm not gonna do that. I'm going to simply use it user.name, and I'm going to say this one dev1. So because this folder, I'm taking this folder as a developer1. All right. I simply click OK and say config user.email. What kind of emails? I'm going to say dev1@gmail.com. I don't know if someone really have this real email, so I don't think I'm violating any privacy. I simply say dev1. Probably maybe there's someone has this email, but anyway, git config user.name, given a name, and user.email, given an email, and that actually completes your setup. If I simply say git status, it is telling me very clearly that no commits are made yet. No commits made essentially means no version is being marked. Okay, and it has a one untracked file which is index.html. Of course we know it. We have created a file index.html which contains a few lines of HTML code, and there is a big header saying that this is Git tutorial. All right, so I have set up the Git. Now I need to add this file to my tracking. Okay, so that's the next thing anyway. So that's how you set up and look into the status. That's what this slide says. So we have successfully set up the status. For simplicity, I have mentioned the commands over there: git init, git config. You can remove the global. I mean, you can keep the global because you might be only the developer working on that system. So global is pretty fine for you. For me, I'm going to use multiple developers. Like I'm going to just simulate a situation for team working. So I removed the -- global parameter. Then I typed in git status, which is showed exactly what it is supposed to be showed. It says there are no commits, as well as it says there is a one file which is not tracked yet, untracked file. And untracked files are shown in red color, as you can see. Clearly says it is not tracked. Okay. Now I can start tracking it, right? For tracking it, we need to add the file first. It's something like let's say before making your versions, you have the versions, right? Version 1. But even before making this version, you would have intermediately saved, all right? Because you don't want to lose any work. So you keep on saving. After some work, then say, okay, that's good. Then you make a version, right? This saving in GitHub language can be called as, let's say, stage. And it is done by using a git command add. When you say git add, it's very much like you're saving a file, temporarily staging the work, right? It's not yet versioned, but it is just saved. You can unsave as well, undo as well, but I'm not going to go there. Right now, I'm going to simply add this by using a command git. I don't know if it is visible, so I'll just anyway highlight it. Git add index.html. So this is the command. So I'm adding this file. Is there a space before? Let me remove that. No, no space. Okay. So, okay, git add index.html. By doing it, I'm not creating a version, I'm staging it. That staging is between versioning and the actual changes you made, all right? If you want to add all the files in this folder, I can simply say git add and a dot. That will add everything in the folder. But right now, I'm going to simply say git add index.html. It has added the file, and then I say git status. Then you see that still no commits yet because I haven't committed, but my file, which was in red color before, has turned into green color, which means there are some changes which has been saved and ready to be committed. And this is called as stage. All right, I staged my changes, and I can even unstage it by using this command, remove the cached, and then you can simply give the file name, then it will undo it, right? But once you commit it, it is versioned. You cannot undo it, right? But, so I can do many small works, changes I can do, and I can keep on saying add, and once I'm satisfied some significant work has been done, then I'm going to commit. When you commit, the command you use, it simply commit, git commit, and then I'll give a small name for the commit, right? Because that makes it more readable. I'm going to say git commit -m. -m means the message, then the name. I'm going to say this is my initial commit, because that's the initial commit, isn't it? Initial commit. And then I click enter. It simply says one file has been changed, and there are 14 insertions you can see over here. All right, this means that there are 14 lines has been added, and then it has given me a code. This code, what you see here, BC45A08, it's a ID. It is very similar to what you actually do here. You have a file name, let's say, I don't know, some file name, and then you have this, you know, v1.0, and then you can put a dot and some extension here. So this is what we call it as version. In Git terms, it automatically creates an ID for every commit. All right, so that if you want to come back to this commit, we can simply, from any point of time, you can come back to this commit by using this ID. Wonderful. Let me clear the screen, and let me again say git status. Now it says that, hey, you know what? There are no changes to be committed. That's correct, because whatever we have already done, we committed it. So we have actually created this one. This is a initial commit, and we had some ID for this. What was that? Some like 5, 4, 6, I don't know, C and some alphabet, some ID we got here. Okay, that was the first initial commit I have done. If you want to look in a graphical way, right, the way I'm looking at here, that's shown in the picture, if you want to look at it in a GUI graphical way, there are softwares. You can simply type in Git GUI, and you'll find the same file, but you'll find the recommendations. Okay. GUI clients. right? Graphical user interface clients, and there are many. Source Tree is a free one, and you could actually go to Source Tree, download for Windows, download for Mac. I never used it because I normally don't look into a GUI. I always have a track of things, but let me show it for the beginners. This might be helpful. So I'm going to download right now before you. I never did it before, so I have to expand this and install it. I'll do it. Double click. And then I'm going to install this. Okay. Is anything happening? Okay. Cannot be opened because Apple cannot check for a malicious software. Okay, this software needs to be updated. Contact the developer. Okay, so I can do this by going into my settings and just allowing this for this one time. Let me say privacy or security. Then okay, firewall. That's general. Okay, so I can say open anyway. I can say open and mount application folder. Okay, now I can install. Well, I'm not gonna create any things over here. I'll simply skip it. I'm not going to create this as well. Can do it later, but for now. Okay, great. So I can connect to the global or local. Right now I'm gonna look for the local. So I can scan a directory for it. We know the directory. It's in a desktop, Git tutorial, and dev1, isn't it? So let me find that. Desktop, Git tutorial, dev1. That's a folder. So I'll simply say scan the folder and say add repository and say okay. So you can see that it already detected the div and it has a master. And if you just open it, you can see the master, and you can already see that the name I have given is initial commit. I hope it is visible. I don't know how to make it bigger. Let me see if I have appearance like mode dot mode. Okay, I don't have anything. I haven't used this before, so hope it is visible. So so there is a initial commit here. This is the name we are given for the first commit, and then you can see here the bunch of lines I have added. I'm trying to make it big. No, it's not happening. Anywhere you have view percentage? No, nothing. Okay, so these are the files I've added. Actually 14 lines to be more precise, including the blank ones. I can see the plus symbols over here. It's counting for that. An initial commit, and okay, for now ignore this master. That's the branch we are right now. Okay, so that completes how to add and commit the first changes. Well, in this slide it's also asking me to do further changes. Let me do that. I'm going to go into the same file, Git tutorial dev, and I'm going to open this file in a TextMate. I guess it's already open somewhere. Let me open it again. Okay, cool. So I'm going to create another change. I'm going to type in more information. For example, I'm going to do some styling. Let's say dot box, for example. I want to create a box which will take a width of 90%, and you have a padding or margin of 25 pixels. Okay, so 50 pixels. All right, and then what else you would like to have? Okay, that's good enough, and yeah, that's good enough. I can also define some colors. Let's say I can use it background color. It's red. I can copy paste this for making it green, for example. Yeah. Okay, I can also make another one blue. These are all simple HT, CSS classes I'm typing right now. Okay, so nothing. Probably I should not have done this anyway, so please don't get confused. Simple CSS file. I'm styling the this one so that I can make it as a class, and I can give like a box, and then I can give a red color to it. Or maybe I should also put something like align, text align, center. So it looks nice. Whatever I write comes in the center. So I'm going to save this. I've made quite some changes. I've added, I don't know, at least 4 to 5, 6 lines of codes. I'm going to now look at my repository and say, hey Git, could you just scan what happened? And it says, yes, you have modified the index.html file, which is precisely what I've done. Then what we do, we add the change. You can say git add index. What it does, it stages this change, which means if I look at the status, it still says modify, but you can see that it is in green color now, saying that it is being staged. It's ready for commit. Then I do git commit. I can put -m and say second changes. First was the initial one, so I'll say second changes. Changes. I'm just giving any name, fine. Okay. And then I look at the git status now again. It says nothing to commit. It's clean, and I can go back to my source tree. This is a source tree, isn't it? Okay. Yeah, I also have this. So I can already see that my node, my head, my pointer has moved to the second one, which is second changes. What I've done in second changes, I've removed this line essentially because there was a line saying style and style closing, but I made it 2 lines. I added all of these lines. I removed this one, added this one. It's clearly saying all the green lines are added and these red ones are deleted, all right? And it is given a name called as second changes. So it simply shows graphically. And the second change has a name as well, and that is 3A, 4B, 2A. So if you look at my slide, so this C1, second change, got a name. Okay, I can also know the first one now. BC45A08. So this is BC45A08. Okay, and this one is 34B2AA. 34B2AA. Also remember, these are all actually short names. The longer name is actually here. If you can see, the actual ID of this one is this complete thing. All right, and what we are using is actually first 7 characters, numbers of characters, whatever it is. It will be obviously crazy to remember this entire big one. So the first 7 characters is actually good enough to move between the heads. Okay, great. So that's all. We have installed the Git. We have committed our, basically added a file, staged it, committed it. We did another commit, so 2 commits, and we also managed to visualize both the commits in one of the GUI, Git GUI tool, which is source tree, and I can see already how it looks. Okay, so this is what happened, all right? So we have added in the working directory, which in my case is actually dev1 is my working directory. In this directory, I have added a file called index.html, put some code in it, and then I use the command git add. It staged the changes. Then I use command git, and I also put -m, and I said initial commit, and then it has committed it and created a node, basically a commit, where you can always go back, all right? And this is actually local repo because everything happening in my Mac. In this session, we also look into the remote repo. For now, everything is happening in my Mac. All right, so that's all we have done till now. Okay. Okay, before going to remote, let me also show you how do you go back in time, all right? So let me look for this one. This is the file we have. So all the changes we have done reflected. We created a box, we created something, and I'm going to do more changes now. So I'm going to say, I'll put a paragraph tag and say this is done by dev1. This is a cool project, whatever it is. I'm just writing anything I want. I saved it again. I'm going to go back and repeat the steps. I'm going to say git status just to check. It says yes, I have changed something. I'm going to say git. I'm not going to add and commit. I can do it in one go. The command for that is git commit minus a for add and m for message. You don't have to run add command. We can simply run one command saying commit am, and then I can give a message. Okay, and the message is, it's actually third change I'm doing it, isn't it? Third change. Okay, done. So, well, obviously, if you look at it, it says done by dev1. This is a cool project. You can see over here. So that's what we expect. Great. And if you go to my visual GUI tool, it also says that, you know what, we actually had initial commit, second changes, and as well as a third change. Okay. Now, for whatsoever reason, I want to go to my second change. All right. So I want to go back, navigate back in time, back in the previous version or previous commits. I can literally do that by using a command called checkout. Okay. Only thing I have to do is say checkout and then give the ID of the commit. We can copy this ID of the commit. So I want to go to the second one. All right. So remember, in the second one, this particular sentence is not there. Rest is all there. Okay. I'm going to go here and just copy this, this ID, which is the commit ID, which is 3. Remember, we also put it over here. This one, the 34B2AS. Okay. I'm going to go to my command prompt. I can also do it in GUI, but command prompt is much clearer. Git checkout and simply paste this one, which I've copied. Oh, okay. A lot many things came in over here. I just want this. Okay, copy. So I'm going to clear and say git checkout and simply paste that one. Okay, that is the ID of your the second commit, the second changes. I click enter, checking out, you are detached from the head, etc., whatever it is. Now we literally moved back to second change. How do you check? You go back to the file and simply press F5, refresh it. You see that it went back in time. The changes we add is now not there, right? Even in my notepad, you see that whatever I have added, the paragraph and everything is gone. It just disappeared. So we actually moved back in version, just like that. But the commit is non-destructive, which means no information or code you have committed will be lost, right? Which is essentially what this diagram is showing. So we have 0, 1, and we also did a 2 now, which was, what do you call this, third change or something. You can move back and forth in this commit. At any point of time, none of your code is lost. If I want to come back to the original one, in fact, the main thread we actually call it as a branch. We are currently, the default branch is called as master, right? If I can simply say checkout and give this number, all right, but I simply say checkout master, it will come to the latest version automatically. So if I want to come to the latest version, I simply have to say git checkout master, and that's it. Now we are back to the latest version, which apparently should contain the code which is done by dev1, whatever it is. So you have to take a time to practice. You can simply use checkout command with an ID to go back and forth in the time in whatever manner you want. Okay, so that actually completes this slide and this slide as well, because we used checkout. So checkout will help you to move back and forth within the comments. It all sounds great I did mention that this is non-destructive. I mean, you in industry, you cannot really erase anything. But what if your Mac or your laptop, your computer go bust? I mean, you can simply, your hardware can go, corrupted, and your hard disk can fail. What happens then? Well, in that case, you lose all the file codes and everything you've done, because everything is in local. To avoid that scenario, we could maintain the same repository also in a remote. All right, you can put it in somewhere in the cloud. For that, we have many providers. We have Bitbucket, we have many providers, but the most popular ones which you are apparently going to use is GitHub. Well, in fact, if you are a developer, if you are a data scientist, you are supposed to have a GitHub account. So what is GitHub? It's a Git repository in a cloud, so that you can push your changes to the cloud. It will keep a copy of it. So anything happens to your computer, you can actually retrieve back. In fact, not just you, anyone from anywhere given access and permission can import the entire repository. Thereby, your code is virtually becomes, no one can actually delete it. It will never be lost. Not just the latest one, all of the history can never be lost. So let's create an account in GitHub. Well, I already have an account. If you want to create an account, you just have to sign in. It's just like you are creating a Gmail. So you just click sign up and give your email ID and stuff. It creates an account. For most of the public repositories, it's actually free. If you want to create more private repository, which is only for your team, you have to pay a small price, like $4 a month or so. All right. For now, I'm going to sign into my own account, which is Ashok Veda. And I have many repositories, not being active currently, but I have a lot of machine learning and AI related repositories. I also have a repository called Git Twit. Okay, so I'm going to simply create another repository, Git tutorial. Okay, and it will be created as Ashok Veda / Git tutorial. All right, wonderful. And then all right, so I already have one, isn't it? So I think just before start. Okay, anyway, so I have Git tutorial now. Where is that? Here. Okay, so now I need to connect my local repository to GitHub cloud or remote repository. Why are you doing it? So that we always have an entire copy in the remote. So nothing will happen. Even if your computer, your hard disk crash, you can always have a copy from remote. That's not the only purpose. There are a lot of other things. Of course, collaboration is the main aspect of Git. So all the other people can connect to the same repository, work together. That we will see quickly in the next topics of this session. For now, I'm going to connect to this repository. And this repository link is actually given over here. So you can simply say it's quite straightforward. Now I'm going to connect my local repo with the GitHub cloud repository, the remote repository. For that, go back here, just clear the screen. So just want to see the status. So nothing to commit. Now I'm going to add the Git repository URL to my local system by using git remote add origin, and then whatever I copied over there, the URL. Oops, that's not the case. They copy something else. Copy it one more time. Git remote add origin. Okay, great. So literally what I'm doing is I'm calling this entire URL as origin. So whenever I refer origin, it literally refers my GitHub cloud repo. Okay. After that, I'm going to simply push, what is my current status. I have created a file, index.html, written few lines of code. Then I did some changes, second changes you can see, and then I have a third change. I'm going to push this entire thing to my GitHub cloud repository. This is what I'm doing. If you look at this one, so now I have created an account in GitHub. I'm going to push this by using a command called as push. This is what it is. I'm going to say git push origin master, and I expect this to go smoothly. It did. So excellent. So the information has been pushed to the cloud. If I go and check in my GitHub repository, the same one, I just have to refresh this, and I see the file which I've created along with all the changes, all the commits is here right now. So this is the same file. This is the same file which you are actually looking at as well. Okay, wonderful. So now that we have created a Git repository, a GitHub repository in the remote repository, okay, I could collaborate with other teammates. That's what we're going to do. For this, I'm going to set up, well, actually, different developers will have their own computers, systems, and work from their own places. I'm going to simulate that by using different folders. I'm going to create a folder called dev2, and I'm going to, that's good enough, dev2. So there are two developers, dev1 and dev2. Dev1 has created index.html, did 3 changes: initial commit, second changes, and third change. Those are the commit names actually. Dev2 has nothing, just starting with the project. I'm going to go to his folder. I'm going to say cd ... which comes to the root directory, I mean the root of this GitHub tutorial, and then cd dev2. So as you can imagine, there is no file, there's nothing. So before developer 2 starts working, it's obviously logical to import already existing code, which is in this case done by developer 1. To do that, he should also connect to the GitHub repository and download the code, which is done by developer 1. The way he does it is by running the same. Now, first of all, we need to initiate the Git, because he should have his own repository. Then do all the configuration, git config, user.name. Obviously, I'm going to give his name as dev2, and then I say git config user.email, and I'm going to say dev2.gmail. Again, someone might really have this email. And then I'll say git status. Well, there is no files, no status. I'm going to now say git remote add origin, the same origin. All right, the same origin. I'm connecting to the same repository, which is nothing but your GitHub Ashok Veda git tutorial.git. If you create your own Git repository, you will have your own URL. Enter. Now I'm going to pull the latest code from the GitHub repository. I use command git pull origin master. Master is the branch name. As I told before, it's a default branch name. As expected, it has pulled all the code. Basically, we only have one file. And now we go to the dev2 folder. So let me just make it like, so this is the dev2. Now I have the file. And if you look into this, literally you have the same code. See, now we have, okay, so let me just, okay, this is a dev2 as you can see here. So this is exactly same as, okay, this is something wrong here. Let me just close this text made completely. Then click check open. Oh, this is the same file. I'm going to open it into the text mate. Okay, great. Now you can see that this is exactly the same code written by developer 1, and this has been pulled by developer 2 through GitHub repository. Great. Now let's see. Now developer 2 wants to do some changes. Okay, so he would like to add one more module. So I can do it right away over here, because this file is actually from developer 2. This is from developer 1. My apologies. And go back. Okay, now this file is from developer 2, same file. So now what I'm going to do, I'm going to copy paste this. There is the ending of this div, that's weird. Okay, I'm going to copy paste this entire code one more time. And then I'm going to call this, I'll change the color into green color, and I'm going to call this as dev2 module development or something like that, and this is done by dev2. Cool. So I close it and I look into Git status now. Obviously I expect that it's going to say that index.html has been changed, and then I'm going to now commit the change saying that change by dev2 changes. Okay, pretty obvious. Okay, and now I'm going to push this change to the cloud. All right, so I'm going to say git push origin master. So what I've done, developer2 imported the change from the latest GitHub repository, from the GitHub repository, which is the latest code, added some more code of his own and pushed it back to the GitHub. So if you go to the GitHub now and just refresh it, I'll just go here, you see that 40 seconds back the code has been pushed, and if you open the file, you see that the code added by dev2 is already here. All right, now I'm going to switch to dev1. Remember, dev1 does not know that dev2 has pushed it, so he is working on his own code. All right, so if you look at, okay, so this is dev2. If you open this up, so you see that there is a development code, dev2 development module, which is added by dev2, developer2. And if you go back to the developer1, his code does not reflect that, because developer1 did some coding and pushed to the cloud, and developer2 imported it, added some more coding and pushed to the cloud, right? So developer2 has added this another block. Developer1 did not pull the code yet, so he is not aware of these changes. And developer1 is going to go ahead and make more changes without importing the actual changes from the latest changes from developer2. So I'm going to simply go ahead and say okay, dev2 and text main. Okay, so see, his code does not have the developer2 code, and he is going to simply add saying dev1 more coding, doing something by his own, and some more coding, okay, and then now he is going to commit locally saying git status. Obviously it's going to say something has changed. I'm going to say git commit -am, a for add, and then m for message, commit message. I'm going to say dev1 parallel changes, or more changes. You can give any meaningful name for commits. Okay, great. So now I look at the status, nothing to commit because the changes I've made is commit. Now dev1 is trying to push the code to the repository, the cloud repository. How do you do it? Git push origin. Origin is the name we have, the name you have given to the GitHub repository, and the branch name is master. Now you see a bit problem. It rejected the change. It says, see, look at here, rejected, because the cloud repository already moved forward. There is a new commit came from developer2, and it actually moved forward. So this is what happened. If you want to look it into the simple way, so the first change was committed by dev1. It's called as, let's say, initial change, initial commit, and this was called as initial commit actually. And then he has done another commit, and it's called as second commit, second changes or something. I've given inconsistent names, that's fine. And then he has done another change called as third change, and then he pushed it to the cloud repository. So the cloud repository has C1, C2, C3. But then in the cloud repository, dev2 actually pulled C3 and made more changes, added his own module and committed again C4. Okay, the blue one is done by your dev2. But now I have a problem because parallelly, what do you call this, dev1 also done another change. This is a local change C5 and he wants to push it to this one. He cannot push because the master has moved forward. This is a change, the blue one done by dev2 is already moved, and C5 is actually the master node moved forward in the cloud, and this you cannot merge it, so it's simply rejecting it, saying that the status has changed now. So the only way we can do right now is actually pull this one back and resolve locally and then push it to the cloud, and the pulling has already happened. If you look at the code, okay, so it rejected. Now I'm gonna pull the code. All right, so I'm gonna say git pull origin master. What happens? It's gonna pull the changes done by dev2. Now there are also changes done by dev1. They're gonna conflict. And yeah, it's asking a name for this pull, so I'm going to simply say conflict something. Oh, it's actually merged it. That's very good. Okay, so successfully it has merged it, and then you see that the new code is automatically merged with the code which is done by the dev1. Let us take a look what happened. So what happened is, because we did not touch this part, so it's nicely added this which is done by dev1, and it has pulled the code from dev2 without even asking me. It merged both the code and made it into one file. Wonderful. Now I'm going to simply push it back now. Now I'm going to commit one more time because now the changes are made recursively. So I'm going to say commit -a, I'll say conflict resolved. Excellent. So actually there is nothing to commit because it's already committed. When we pulled it, it's already committed. I can simply go ahead and say git push origin master. Now it will be successful. So now what I have done right now is I have managed to pull it, and by pulling it, it has created another commit, say 6, which is actually a conflict resolved commit, which means the changes which is in C4 and C5 are merged. Actually it is merged into C6. Now it has become one branch again. Okay, that's wonderful. I mean, even if you go to this visual thing, you can already see, like, actually I don't have to draw because this is exactly what it is. Well, it's horizontal, it's vertical, but you can already see that from here the dev2 has started doing some changes by himself, and dev1 also did a commit, and when dev1 tried to push it, it rejected it. He pulled it, created another commit which is a merger of these two, and then it back to one branch. So that's how teams can collaborate. It doesn't matter if you have 2 team members, 10 team members, 20 team members. They can more smoothly communicate through the GitHub repository. So they have to pull the changes, resolve the conflict manually, push it back, and they all can work together in a project seamlessly, even in the same file seamlessly. Most of the time, Git automatically resolves the conflict. If there is a changes happening in the same line, if the developer 1 did some changes in the line and developer 2 also did the changes in the same line, then it will give it to you to manually resolve it. Otherwise, it recursively automatically merges the changes. That's very convenient. Alright, so that's how things, I mean, I have put dev3 as well, but I think you got the point. Dev1 and dev2 in the similar manner, dev3 can smoothly collaborate in the remote repository which is GitHub, and thereby you can create a more seamless and no one work is being lost, because any change you do locally, commit it and push it. Every commit you do, even locally, will be a commit, and that commit can never be deleted. You can always go back and forth so that you have complete, the code is never lost. Whatever you commit is always available. We could also create branches. So when you need a branch, like when you want to create another feature or another module which is developed parallelly by a separate team, which is not in, it doesn't need to be on the master. For example, let me create a branch right away. So I'm going to say creating a branch is pretty straightforward. Git branch, and I'm going to call branch branch. I'm going to call this branch as auth module, like authentication module. So that's a separate feature in the same project done by authentication guys, different developers maybe, right? In this case it's the same developer one, but he wants to bring in another branch and work on it without getting disturbed by the changes happening in your main line, the master branch. Okay, when I click enter, the branch is already created, and then I can simply say branch to see which branch I am right now, how many branches we have. So you can literally see we have 2 branches. Auth module is the one I just created, and then master is the actual main branch. All right, and you can see the master in the green color, which means that the current cursor, the head, is actually on the master branch, right? If I want to switch to the auth module branch, which in fact a copy of the master branch, because when you create it, it creates a complete copy of the master branch. All right, if you want to switch, it's simple, same command, checkout. The checkout is also used to move between the commits. The same command used for also the switching between the branches. I'm going to say auth-module. By doing it, I switch to the auth module branch. How do you know? Well, I can again say git branch. Now you can see that auth module branch is in green color, saying that that's the branch I am right now. And this branch contains all the files of master's complete copy of it to the latest whatever we have. Wonderful. Now I want to do some changes in the auth module branch and then try to merge it back to the master branch. So I'm going to go ahead and say, I'll just go here, and obviously this is in auth module right now. Okay. When you change there, it's automatically changed the branch. So now I'm going to just copy one more time and say this is a, I'll make it blue color, and this is a auth module. So I'm going to say this is authorization or authentication module, done by dev one, but whatever, coding. Yeah, some coding. Okay, cool. I saved it. I go back. I say git status. Now it's always going to say that something has changed now because I just changed it. All right. I'm going to say git commit am auth module changes. Okay. Okay, great. So if I go back to my this one, open it up, you see that there is, well, the blue is too blue, and then you can see that there's a new module being created called as auth module. Remember, this is happening in your branch, which is a auth module branch, which means if I switch to the main branch, which is a master branch, you will not be able to see this change. Let me do that. How do I change into the main branch? Well, we have our checkout command, pretty straightforward. Checkout master. Master is the default branch. That's all. Now I go back to my browser, I refresh it. You don't see that auth module because auth module is only in your parallel branch, which is your auth module branch. Great. I'm going to do some changes in the main branch as well. When you go to the code, you also see that whatever we have copy pasted, the blue one is gone now. All right. So I'm going to do some changes here again, saying dev to dev one, doing some changes parallel with auth module in the main branch, in the master branch. Okay, some info. Okay, And then again I do the git status. It says that something have changed, and then I say commit -am. I'll say more changes master branch. Okay, done. I'm going to now push it to the master branch origin, like in the cloud repository, origin master. Okay, great, I pushed it. Well, now the changes I have done in this is obviously reflected in the master branch. See, this is the line I just added. Some spelling mistake, please ignore that. And if I switch to obviously the auth branch, I will not be able to see this one. No, not branch, I have to say checkout. When you say branch, it creates a new branch, so checkout. So that change is not there, but you have the auth module. So I have taken another branch, did some changes for the auth module, also did some changes over in the main branch. Now I need to merge these two so that they can, like, basically the new feature has been merged back to the main one. For that, we have a very simple command, as you can guess, merge. So we simply say merge, git merge, which branch I am right now, auth mod. So I'm gonna switch to master branch, and then I say git merge auth module. Then it's asking some name for it, so I'm gonna give some name, saying auth branch merged. Okay, great. So now both branches would have been merged. So now if you look at this one, you just refresh it, you see the changes I have done it in the master branch and also the auth module, both are in the same one. And if you go back to your visual GUI, you can already see that this is the auth branch. I have done some changes in the auth branch. I have done some changes in your master branch, and both got merged. All right, so I hope this has given you a fairly good idea. You can, I mean, it might look a bit complex when you look at it for the first time, but trust me, it's a pure common sense. It's almost like what you're doing with your versioning in your files in a manual way, right? It's just that it becomes much more smoother, much more automatic. You do not have to worry about anything. You can go back and forth in the commits by using the commit IDs. You can create more branches and you can merge them so that you can work parallelly. And the best part of it is multiple team members can work together. If you look from an AI or data science project perspective, there are, if you have big project, some people will be working on data preparation, collecting the data, blending the data, creating new variables, derived variables. Some people are working on analysis, exploratory data analysis. They look at the variables, they see outliers, cleaning them, all of these things. Statistical analysis essentially. And there is a bunch of people working on modeling and as well as evaluation. All right. So, well, if it's a big project, you have a bunch of people working on each of these phases, and they can all work together using a Git repository. So it's not an optional thing. You need to know Git, and any further projects you do, it is highly recommended that you use GitHub as the main source of your repository. And trust me, if you play with all the commands which I've just described, which is there in the screen as well, a couple of times, you intuitively understand the names, and the way it works are pretty straightforward. All right, it essentially creates a commit, and then you can go back and forth in the commit. You can create branches, you can create commits on the branches. It becomes pretty simple once you do a hands-on and practice a bit. Okay. The key benefits of GitHub is, of course, it saves a lot of time. You can work offline and commit and then push it to the cloud repository whenever you want. You can undo the changes and mistakes. You can go back to the commit and then again create another commit parallelly, and you can basically do things. You can track the changes to any time you want, and it is very compact. It's not like your traditional copying the files. It only saves the changes. Every commit changes the delta, the changes between the two commits. So it's really compact. Branching is easy, lightweight, fast, reliable, secure, open source, economical. So there is no reason why you should even like not use GitHub for even a small project. Even you're working for yourself, like you're alone in a project, still you can use GitHub because it's really efficient. It helps in many times. Your code once committed becomes, it's impossible you lose it. You always have it. So I wish this video helps you to learn all the key aspects of the Git and start using it. If you like this video, if you find it useful, please subscribe to the channel and also click on the notification button so that when I record another video, you'll get an alert.